My name is Jim. This is Design Validation Tools inside of SolidWorks. Whether you are new to SolidWorks or you're an old veteran, I'm going to walk you through some tips that will make you more efficient when working with tools that are found in the Evaluate tab. So as far as what we're going to cover, the questions that come to my mind are, have you ever wondered what or how to use a design study, or have you ever wondered what the thickness analysis tool is for? Well, I'm going to cover a lot of these tools and then some of the other enhancements that have been made to others during the course of this hour. And I won't have time to cover them all, but I'll do the best that I can. There are a lot of very different tools for various industries, so you may feel as if you're drinking out of a fire hose on this one. So it's hard to have a great flow when covering this many tools. However, the flow is pretty simple. I'm going to cover the Evaluate tab for part documents, assemblies, and then finally drawings. And drawings will be the shortest. There's not quite as many Evaluate tools inside of the drawings documents. I'm not going to go through a bunch of slides. Everything that I do is going to be covered inside of SolidWorks, so I'll do the best that I can to show you the tools live up here on the screen. The first couple of tools that I'm going to bring up as far as design validation tools are concerned are the bigger ones that are more in depth, and then I'll jump into some of the smaller tools as we go through. Again, for those of you who just joined us, I'm going to be covering the Evaluate tab for part documents and then assemblies and then drawings. The first one that I want to jump into is the Design Study tab. Actually, before I jump into the Design Study, I'll mention the sensor that I want to use for this. This oil pan that I have here has two bodies in it. The second body is a volume. In fact, I'll go ahead and show that so everyone can see it. And the volume is based on the surfaces that I have on the inside of that oil pan. Well, I'm going to go ahead and hide that for right now and create a sensor. And with sensors, I'm going to be using this for many areas in this presentation. We'll go with mass properties. I want to create a sensor for volume and choose the body, since we have two of them in here. And it shows you what the volume is right away. So we could use this sensor to monitor what the volume is as we make changes to this design. Well, I'm going to go ahead and rename this too, so we know what that's being used for in case we have multiple. And the design study, this is something that's been added to the software back in 2010. It's used for all SolidWorks users, even if you just have SolidWorks Core, but this is also utilized for simulation users for the design scenario for linear static studies. It's also used as the new interface for optimization studies if you have Simulation Professional. But I'm going to show it as if you only have SolidWorks Core. The Design Study tab will show up down here at the bottom. And we're going to fill out a couple of these areas, the variables that we want to change in this oil pan. We can add parameters, and just to save time, I've already added the parameters for length, width, height, and the draft angle of this component. So we're not going to do that right here. And then we can specify those from this list. We'll take a look at length, and we can specify a range of values for this variable. In fact, there's different ways of applying these values. It can be just a range, which we're going to use, or a range with a step, so you can specify an increment, or even discrete values that are separated by commas. For this length, I want to range between 16 and, say, 20. And for the width, we'll go ahead and use a range for that as well. We'll go between 10 and, say, 14 inches for the width. And the height, we'll use a range of, say, 6 to 10. And an angle, the draft angle, we'll just keep that a range from 2 degrees to 6 degrees. And then we have to have a goal in this case. Our goal is the volume that we had just inputted as a sensor. And we want that to be as close as we can get to 1,200 cubic inches. When I click Run, SolidWorks is going to run several iterations. The number of iterations is determined by the number of dimensions that you have in your design study and the type of range that you have. Is it an infinite range, or is it range with steps, or is it using discrete values? It will figure out the number of iterations it needs to run. And you can see the preview of each iteration up on the screen too. Well, in the end, it's going to give you an optimal design, and we can see that right here. This is my optimal design using these values for those dimensions, and here's my my volume. We're very close to 1,200 cubic inches, which is good. And it also keeps track of all the other iterations that it ran, so you could see what those dimension values are and the volumes at the bottom, or the goal at the bottom. Another power behind this is the current tab, because this gives me the ability to use the clipping bar to move this between those ranges for those dimensions. So I could change the values in here. Notice that the model updates as I do this, and it shows me what the volume of the whatever it is, the oil or whatever I put in here, it shows me what that volume is on the inside. So again, this is available to all users. There's more capabilities if you have access to SolidWorks Premium or Simulation Pro. Let's take a look at another tab, or another option that's inside of the Evaluate tab. I'm going to be jumping kind of all over the place here, but the next one is another bigger type of a tool. It's DFM Xpress. And DFM Xpress, it's going to enable you to design with better confidence for manufacturability. If I take a look at the settings in my task pane, you're going to start by picking the type of part that you have, and then specify the rule parameters that are based off from machining operations in this case. And those rules are things like the hole depth to diameter ratio, the mill tool depth to diameter ratio. Based on these set of rules, when we click on Run, it's going to check your geometry and then give you some areas of concern. And we can take a look at the report right here inside of the task pane. It's going to flag you for some of those areas. And as we pick on these flags, notice that it highlights them right there in the graphics view. Now, one of the things that I like about this is you can keep that tool up. So if we take a look at some of these sharp internal edges, when we take a look at those, it's highlighting them. So right away we can go ahead and add a feature to that. Maybe we want to round that off to 3 millimeters. And we're still inside of the DFM Xpress tool. Again, if we want to, let's see, what else do we have? Non-standard hole sizes. If we want to go ahead and edit those hole features, I'll make those holes a little bit larger and make them standard sizes. And when we're ready, we can go ahead and run this again, and it will update this screen with these flags. So we'll notice that we just have a couple more areas of concern to take a look at. So again, it's a nice tool, a nice interface that stays up on the screen as you're modifying your component. Well, let's take a look at some of the other smaller features that we have inside of the Evaluate tab. I've got a couple other parts that I want to bring up. This one, I'll use it to show a few of these options. The Deviation Analysis, I think, is the first one that I want to show. With Deviation Analysis, you have the ability to select edges and have SolidWorks tell you what the angle of the two faces are between those edges that you selected. And you can specify the number of data points that you have along those edges as well, or arrows. When I click on Calculate, you'll see arrows will show up that will give you the deviation between those two faces. We have minimum deviation, maximum deviation. It adds color, so it makes it easier to read. Average deviation. And And a lot of times you might use something like this on faces that look tangent, but you're not quite sure. You can find out if they're tangent very quickly by using deviation analysis. Another one that I want to show on this component is the curvature option. When you right-click on a face, there's two items in here, curvature and zebra stripes. And I have these shown all the time. This is most of you know that you can customize these pull-down menus. Show the curvature on just one face, or up here in the Evaluate tab, show the curvature for all the faces in the design. Well, as I move my cursor over that face, first of all, it's going to let you know what the curvature and the radius is, right where your cursor is. And it uses these colors to make it easier to find out where the your highest radius is or your smaller radii are. And the color range is basically from black to red. For example, black in this case being the smallest curvature, which is 0 right here, flat face, to red being my largest, or I'm sorry, my smallest radius that I have in the design. Or if I turn this over, you notice that this area looks black, but it actually does have curvature to it. It's got a huge radius on it. So again, you can it helps you to find out where your minimum and maximum values are in this component. Now I'll turn that one off. There's another one that you might want to look at. It's zebra stripes. And zebra stripes are going to help you to find out if you have any imperfections or wrinkles in your design, if you have real fancy parts like this. And a lot of users will ask me, well, what exactly do those zebra stripes mean? What are they? Well, first of all, my colors are different. They typically show up as black and white. But in my case, I changed them just for the fun of it. Now, if you look at the tan color edges, see if I can zoom out a little bit here. I want to get to a good spot. Imagine that these tan colors are the reflection of a room. So if you have a room behind this component, this might be a wall of that room. And imagine that these lines are straight lines on that wall. Well, this is how they're going to reflect off from your component. So this would be the corner of that wall. This is the ceiling up here. This is the floor. Okay. Or actually, what I did is I put another body in here too. At the bottom, this is a sphere. So again, when you're looking at this, imagine that this is a wall that's on the other side of this component, and it's reflecting off from it. There's a corner of the wall, the ceiling, the floor down here in the bottom. This is how it would reflect off from that part, if that gives you a better idea. So again, it's going to help you to find these imperfections. A lot of times you'll find that just using shadows and lighting conditions on your component that you can find them just as well. All right, well, let's jump into another component. The first thing that I want to do with this one is mention curvature again, because curvature doesn't have to be just used for fancy components. When you pick on this, again, this will help you to find out anything that's black is going to be flat, of course. I have a lot of constant radii fillet on this component. As I move my cursor over it, it's going to let me know what that radius is, just by moving over those faces. And of course, then if anything is red, I know that those are the smallest fillets that I have on the part. Or if I flip it around, I'll notice this blue one that I have in here is the largest fillet on my component. So I can quickly take a look at or interrogate the radial faces that I have in my design and see how big they are. Another item that I think is probably underutilized is the thickness analysis. Thickness analysis can be used to find out if I have any thin areas on my model. Let's minimize this here. For example, I'm going to start with a target thickness of 20 millimeters. And when I calculate this, I'll find out what faces in my design are thinner than 20. Well, again, now as I rotate this around, we'll find out where some of our areas of concerns might be. If I'm looking at red, it's showing in this case that that face is 2 millimeters thick, and that might be a problem for me. It's a lot easier to find out where these are by using thickness analysis. Okay, and then we can take action on this, once we've interrogated our model. Now this is used not just for thin regions, but for thick regions too. In fact, I did this just for fun. I pulled up one of my favorite models, which is Homer Simpson. Now this is the exact opposite. I'm not going to run this one just to save myself some time, but this is, again, thickness analysis, but the reverse of what I just did. I want to find out what the thickest faces of my model are. And then I might be able to remove some of that material if I don't need to, if I don't need it to be that thick, things of that nature. Here's another one. Again, I'm making you drink out of a fire hose here. There's so many of these tools that are in this Evaluate tab. The symmetry check. I may look at this model and say, well, a lot of these items look symmetric, but rather than guessing the symmetry on this component, I can go ahead and select a plane, a center plane, through this model and run symmetry check. And this again is going to evaluate all the faces that you have on your design and use colors to show you what is symmetric in your design. Obviously the faces that are green are symmetric, or yellow indicating asymmetric, or red faces which indicate unique faces on each side. Again, I may say to myself, well, these two look like they're symmetric, but then I can find out very quickly that they're different sizes or maybe even different locations in the design on either side of that plane. Now the design checker is actually something that it's only available to SolidWorks professional users. Almost everything I'm showing in here is available to everyone, but this one is not in core. With the design checker, I'll use this a couple of times in a part document and a drawing. The design checker is going to enable you to build your own set of rules, and it's going to check your document based on those rules. This can be used in parts, assemblies, and drawings. A couple of examples here are the material hasn't been chosen. And you can list the materials that you typically use and correct that right from here. Or fully defined sketches. You can find out what sketches in your design are not fully defined. Now in the Property Manager, we can go ahead and find that out with minus signs that we have behind these features, but I can't see the sketches right now. So I can do that right here. In fact, I can go ahead and edit these sketches right from the this task pane. Let's move this over a little bit so you can see it, and find out what's underdefined on that sketch. This would actually be great for any of you who are SolidWorks professors, or if you're an educator, then you can use this this design checker to find out if the student had fully defined all of their sketches. And there's some other items that I may have in here, like for example, did I use the correct units for my dimensions and so on. A lot of these can be automatically corrected using the rules that you would set up ahead of time. I'll bring this one up again for 2D drawings because that's usually where this is used. And as long as I'm talking about items that are in SolidWorks Pro, I'll talk about this one too, the Compare Document tool. This again, I believe, is only for SolidWorks professional users, but it'll enable you to check your the differences between two-part documents or 2D drawings. And this really comes in handy, especially if you're getting files from other customers, because it works for non-CAD documents as well. If you open up an IGES file from a customer, here, let me pick on a couple of components here so you can see this. Okay, I've got these two parts that look similar to each other. If I get a part from a customer of mine, and it's an IGES file, and I create a tool for this, or a fixture, and then they send me another IGES file that has some changes to it, well, I may ask myself, do I have to modify my design? Is it going to have an effect on what I did? Well, rather than guessing or looking at those models manually, we can do a geometry check. And this will analyze all the faces, all the geometry that you have in this design, whether it's a SolidWorks part or if it's a non-SolidWorks part. And it's going to give you a report and even highlight the areas that are different between these two designs. Now, typically what I do is I click on this second tab that's going to show me the differences between these two components. And take a look at the face comparisons. You would especially use this if these two parts are IGES files, or if they came from other CAD systems and you don't have any feature data. Well, see up here at the top, it's going to show me in red any differences that I have between these two designs, whether it's an addition of material or it's a subtraction of material. And we can, as we rotate this, you'll notice that it's rotating them in sync. So we could look at both at the same time. So it's a very useful tool, again, if you need to compare two files that you have received from a customer. And again, this can be used in 2D drawings as well. The rest of the items that I want to show in this part are available to everyone. The measure tool is something that many of you already know how to use, but I'll mention one thing in here that you might not know. When I measure the distance between, for example, these two holes, I might want to monitor that or keep track of that as I'm designing this part. We can save this off. There's a little save button in there as a measurement, and there's a number of options that you have as far as if you want to measure the normal distance between a couple of items or what it might be. When I accept this, it shows me the measurement under sensors, and you can rename these as well. Now I can keep track of that at all times. Speaking of sensors, there's a number of sensors that I might add to a component. I might want to keep track of the mass of the component. We can go ahead and accept that. And again, this is always going to display in my feature manager as I'm making changes to my design. So I'll mention a few of these as we go through parts, assemblies, and drawings. One more item that I want to show in this component is statistics. With statistics for part documents, you may want to know, you may want to have an idea of how long it's going to take to rebuild this component, and what features are the most performance-intensive features that you have in your design. And in this case, my features are pretty much the same across the board. So I don't have one feature that is really just killing my component. Many of you who have been using SolidWorks for a long time know that the simple features, like even linear feature patterns, can be very performance intensive and will probably show up at the top of your list. So if you could use this as a learning tool to find out exactly what features do take up the longest time to rebuild your part. And you can actually right-click on these features and edit the sketches and features from there while you're inside of this tool. The draft analysis tool, real quickly on this, with draft analysis, this really comes in handy because when you select a plane or a face to use as a direction of pull, you'll get red and green faces for the positive draft and negative draft in this component, and yellow indicating areas that don't have enough draft. And those yellow areas are basically anything that's less than the value that you put into this box. And I'll notice on this face it's actually 0 degrees. There's no draft on that face. Well, one of the benefits of this is it keeps the colors up on the screen, so that as you edit the features, it will change the colors of them right away. as you make those changes. I'll do this one again. Okay, let's make that angle a bit different. And again, the colors will stay up here, and you'll have a legend down in the lower right-hand corner. If I add draft to that face, or in my case, to save time, edit that feature, we'll just add 1 degree of draft. You'll notice that the colors will change right away. And when you're finished, just simply in your Evaluate tab, turn off the Draft Analysis tool. Undercut Analysis is another similar tool. You can use this to find out if there's any red areas on your design where there's where you have dialogue or something of that nature. It will indicate those in red. You may need to generate a core for that or make a modification to your design. All right, now let's take a look at assemblies. With assembly documents, I think interference detection is something that pretty much everyone is familiar with. You have the ability to select the entire assembly to find interference, or select a number of components for interference detection. And as you pick through those interferences, you can change the options down here for visibility of the non-interfering components. We can, for example, make those hidden. So as you switch between these, it only shows you the interference between those parts. And we can ignore interferences in here too. For example, I just picked on that one to ignore it as we scroll between these. But another one up here that may come in handy is clearance verification. And I suppose with clearance verification, I may want to keep track of components that are within a certain distance from another part. For example, if I pick a piece or a component, or I choose a face, I can calculate to find out if there's any parts that are, let me see here. Oh, there we go. I can find out if there's any parts that are within a certain distance to that component. And it will highlight those pieces for me. For example, if I change that distance again and calculate this, it's going to let me know what components are within that distance from that piece. I don't believe that this tool works as you're moving the components. It is more of a static function. And then hole alignment can be a huge issue if you're making components and you find out later that your holes are misaligned. So we can use this to find out if there are any misalignments in our assembly. And it's only going to check the holes that are within a given deviation. So we can go ahead and type in a value here, and it will check all holes that are within that distance from each other, where their axes are within that distance from each other, and calculate it. And so here we do have some deviation between holes, and you'll notice that it will highlight that set of holes. In fact, we can zoom to that selection to find out where it is. It's a little close there. And you can see, of course, I do have a misalignment there, and that might be hard to see unless you're using this tool. So it will let you know what the deviation is. Right now it's 1/8 of an inch off. Well, we can go ahead and modify the part once we find that problem or that area of concern. So I may want to change this dimension for those hole locations so that it looks right. And of course, then I can run that hole alignment tool again, just to make sure there's no more misalignments in my part or my assembly. I suppose the other is, if I'm talking about the measure tool, I mentioned that over in that other part. Again, with the measure tool, we can specify faces that we want to measure between. If I'm interested in the total length of this component, I don't have to make a dimension. We can just go ahead and save this measurement. Of course, again, we can call this, oh, I got an angle in there. Hang on. Okay, so we pick a couple of items. When I save that, we do have options. I didn't change this. We can save the normal distance between those two items. And this can be the total length of my assembly. Again, we can rename these too. Or I may want the total height. Instead of adding a dimension, I'll just pick on these two faces and save it, save the normal distance between those two. And keep that in my design at all times. There's many things, items that you can add as sensors inside of your assembly documents. One of them that we haven't seen yet is the interference option, interference detection. Well, make sure that you place your assembly in this selection box here and accept that. And then when we rebuild our assembly document, there we go. When we rebuild, it's going to indicate whether we have any interferences in our design, and we already know that we do. I'm just going to go ahead and suppress this for right now. And there's other sensors that we can have in here. A sensor for the mass of our entire assembly. We can monitor that as we're designing. And now these two, the interference detection and the mass, those can be added to a blank assembly document and saved off as a template. So you don't have to add those every single time you make a new assembly. They're always going to be there. The other one that you may wonder, I'm going to mention what it is, but we're not going to use it in here. Under there's a proximity sensor. Proximity sensors, in case you're wondering, are typically used for event-based simulation. Quite a few months ago, I created a webinar, or I did a webinar on this. Event-based simulation is part of Simulation Professional. If you can create a proximity sensor on a component, so if another part passes by that sensor, it's going to trigger another event or another task that you have in your animation. So that's typically only used for Simulation Professional users. The last thing that I want to mention with assemblies is the assembly visualization. Well, actually, I might mention the assembly expert too. With assembly visualization, this is a unique way of viewing your assembly documents. Let's change this here a second. We can view the mass of these components, and based on that mass, we get a different color that's applied to those components. Red being the heaviest component that I have in the design, and blue being the lightest. Well, you do have the ability to add colors to this. We can add a color. So it's real easy to modify this color legend. And we can also specify different types of properties. For example, instead of mass, I might want to look at how these parts are manufactured. Well, and rather than looking at a fringe plot, we can make this look more discrete. Right-click here and group the identical components, so that any parts that are welded will show up in purple, or purchased components will be in that blue color. My machine components will show up in black, and casted parts will show up in green. So this may come in handy. Again, it's another way of viewing these components. And in fact, you can save this off as a display state too. Add a display state for the how the part is manufactured. Or if I go back to mass, we can create a display state for that. And those display states, if you haven't used them before, are saved in your configuration manager. So here's the display state for how the parts are manufactured and the mass of the components. Again, the last item that I want to mention in here is the assembly expert. This one, I suppose I would use this if I want to find out exactly how many parts I have in my assembly, how many of them are unique, and how many mates I'm using at my top level. Or, some users might want to know the maximum depth of their assembly too, which in my case is 1 because I don't have any sub-assemblies in here. If you had one subassembly, then your maximum depth would be 2. Or if you have 5 subassemblies in your main assembly, that would still be 2. The depth would only move to 3 if you have a subassembly inside of another main subassembly. Well, let's take a look at drawings, the evaluate tool for drawings, and then I can open it up to some questions. We're doing real well on time, so I should have plenty of time for questions at the end. With the evaluate tool in here, I'm just going to mention a couple of things. I suppose a quick one is statistics. I just mentioned it in assembly, so I'll mention it here too. You may be interested in some of these areas, the number of views that you have in your design, or the number of sheets, the number of notes or dimensions that you have in your design. You can check that here. The other thing I want to mention is the spell checker, but before I do that, I want to mention again the design checker, because that will run the spell checker for you. Again, this is something that is available to SolidWorks professional users. When I check this drawing document, it will give me a list of items based on my criteria, what I had specified. Here's a few examples. We have overlapping views, and again, we can go ahead and modify these as we go through this checker, and then we can refresh it when we're done. What else do I have? Any items that haven't ballooned yet will be listed right here. Or if I have any dimensions that have been replaced by somebody who maybe they manually placed in text instead of leaving it as the default value. The spell checker. Now the spell checker, it will just let you know what is misspelled, but it doesn't run the spell checker in here. That's something that we still have to do outside of the design checker. I may also have dimensions that are in the wrong units, or the dimension precision might not be exactly what I want it to be. And some of these can be automated. I can just auto-correct all, and it will take care of many of these for me. Otherwise, I could keep this tool up and walk through some of those changes. For example, this dimension right here, I do want it to display the actual value instead of whatever I have typed in that case. That doesn't happen as much in SolidWorks as it used to happen in AutoCAD. The balloons, I haven't ballooned everything. I have a section view, so I can add the balloons that I can't see in the isometric view. There's the 3 that it was missing. And as far as the spell checker is concerned, we'll click on spell checker. And this is a nice tool because it will zoom into the notes that have any misspellings, and we can make those modifications right here. Well, when you're done, we can refresh this and make sure that all of those areas of concern have been taken care of. By the way, I ran this on just one document, the active document. Using the task scheduler, you can check a folder with several drawing documents in it, and it will generate a report for you on multiple files. That concludes everything that I have for the Lunch with Desai webcast. I do have one more poll question that I'm going to have you answer. And after that, we can take care of any questions that you have. If there's anything that I haven't shown, then we can go ahead and address that right now. Let me pull up that last poll. This is just our standard poll to find out if the webinar or any of these tools were useful for you today. Well, thank you again for joining us. Feel free to visit our website for future webcasts that are coming up. We have another one next Thursday, and tips and tricks that we have inside of SolidWorks. Now, feel free to stick around for a few more minutes if you have any further questions. Otherwise, have a great day and enjoy your weekend.